Bismillah ar-Rahman ar-Rahim, the access control. Actually, this is the third layer of security when accessing resources. Let's start with a small briefing and make you actually on the frame. And then after we continue, we said that the access control is one of the security layers that gives users access to resources. In the sense of to access a resource, you might have an access to a system, but based on your privilege, you'll be able to see a resource or not. Example of resources, files and values, like the transcript and the profile and the grades and exams, names, whatever. All of them, they are values that they can be displayed to you or not, based on the privilege given to you as a user. What does it mean? It means you are a user. Here it is. And you as a user, you'll be actually authenticated face to a system using, for example, one of the authentication mechanisms, password-based, token-based, the scenario of the authentication resource, but whatever, you'll be authenticated using one of the mechanisms. Thus, you'll be accessing the system. You are inside the system now. Inside the system, there is a central point, which is the task of an administrator. It is centralized to award you an access to a resource, the next level of authentication, the next level of, let's say, security. You are inside the system. You are authenticated, means you are a member of the environment. Yet, resources, they are far from you, and you have to be awarded an access based on another security scenario to reach the resources, whatever the resources are. We can talk about values, static values, files, databases, entities, whatever. All of them, they are actually to be controlled by an administrator in a central point to give you or not to give you access to them. There are actually policies behind of that. It is root, this access control actually. We are talking about selective discretionary access control. We are talking about a forced mandatory access control, or based on roles. Who are you? Role, administrator, manager, student, instructor. The role, based on your role, you'll be awarded an access. Or based on the rule, policies and rules, politics that the organization is setting. We talk about attributes. Based on the rules or those attributes, you'll be awarded an access or not awarded an access. You are forbidden. So both sides. There are requirements to set up a policy. From the requirements, it's a common sense understanding, but we start with the least privilege mainly. This is the very important thing, to award the least privilege to be given to everybody who wants authenticated to a system. It means the first interface would give a very least privilege to any user accessing the system until a future time where the administrator and the central point will award you a different privilege, different, let's say, access control right. So here at the beginning, once you be authenticated, you'll be awarded a very least privilege. Then after the access point, the administrator and the access control center point will be actually controlling you and giving you different privilege if you need. Otherwise, you'll be the same privilege. Those are actually a requirement that they have to be set before we talk about any policy behind the access control. Those are requirements. Yeah, the candidates, the actors, building up an access control in a scenario, subject, object, and the right. Subject is the doer, object is the purpose or the target, the right is the way. Method, how? Discretionary access control, or the selective access control, is a first context via which we are awarding access to resources. Why we are setting it as the first priority? Because it's easy to implement, it's easy to understand. We stand on the use of a sparse matrix in order to relate subjects to objects. Subjects and objects, we said that they are one of the actors inside the access control image. So a relationship between the subject is the user, the object is the source. So the relationship here is drawn through a matrix, which is a sparse actually. We may have a relationship which has one role or one right, or we have a different or another relationship that has, let's say, a variety of rights, 100 or 10 or whatever, or 3, whatever the rights are. Or we may have a relationship, no rights at all, to specify that there is no right, no access at all. Thus, it is sparse matrix. So we can read the sparse matrix this way: subjects as rows, objects as fields, and what we see in the intersection cells are the rights. We read this relationship in 2 different ways. Either the file, what rights are given to a specific user, what rights are given to a specific user, what rights are given to a specific user, and so on, until the end, until the last user. Or from the other view, a user, what he can do on a file, on a resource, what he can do on a resource, and so on, other users. So it's a context of a data structure representation of this matrix into a language that the computer can understand. This way we can make a solution that the computer can understand. The same way we are seeing it, but not in a sparse way. It means there is no empty fields here. Every user has group of rights or group of resources. So all of this we saw. It's just to remind you. The sparse matrix through which actually we can see extended givens to be subjects, to be objects. The subjects themselves, they can be playing the role of an object. I'll give you the example. Instructor, student. So the instructor can control the profile of a student. An administrator can control the profile of a worker, an employee. So a worker or a student can be playing the role of an object. It's a resource that the user has to access. And also processes tasks in the computer, what the processor can do. Other objects that might be actually controlled using the discretionary access control mechanism. Or what has to be done as access control in this context, it is from within the environment, from within the system itself. The functionality to be given based on the task, based on the input, it is from within the information system or whatever to access a resource, to access a specific resource. So it's up to you. It's a role to specify. And so it's not a role, but it's a rule. It's a common sense understanding here to relate objects and to create an operation, a task, a function. At the end of the day, a process. Use these accessory resources. Any questions here, please? The context of the discretionary access control is the way how we draw the rights in between the objects and subjects. Means the objects how they are accessed. The context of the discretionary access control. It has to give flexibility. Means it is not strict. Means discretionary access control is not common for every and each single information system, and it is not stable and fixed with the same rights to all users. No, there is a less level of flexibility. It means we can change, we can find exceptions, and all it has to be actually implemented from within the system. Even we can control actually what the user can do from within the memory by controlling the execution of tasks. We remember the data execution prevention solution we saw in the digital security course, and the ASLR, the random access to the memory parts where to execute resources. Also, those are security actually scenarios to prevent malware execution on memories. So this is the same way actually we can control the access to memory locations, so the system level, and we can have another access control actually, which is accessing the hardware through the kernel. It is another access control layer. It is completely different. So we can control the software, we can control the processes, we can control the hardware through the respective entry points. All are possible through the discretionary access control. It's the context of graph to draw, subject object, draw the relationship subject object. In the modern information systems, actually, you talk about operating systems. The access control is drawn behind the technology that Unix operating systems drawn to us. Unix is an open and free open source operating system that gives us the chance to work with a similar environment like the Windows one. It gives us so many distributions. There are actually graphical interfaces that we can utilize with a similarity to the Windows environment. It means we can use graphical interfaces, whether it is an interface to the access to the internet, local network, utilizing a computer application or software application, whatever. In so many views, we are given an on-screen instructions to use whatever the purpose we are behind. So it's an environment that gives us actually a similar view to the Windows. But what's the problem here? It's not a problem. It's an addition. It's another value. That this Unix is clearly drawn the relationship subject-object based on the let's say control units, which are the read, write, and execute. Read, write, yes, read, write, execute. Those are three writes that the subject can do on a file or a resource, or the resource can receive from a subject, can accept from a given subject. So all of this actually, and the first control that we can see through the Unix or upon the Unix environment is using an indexed node, which is a file, one indexed node. It's a file that knows the profile, group of attributes and permissions related to an object that the current users can do. So an inode would draw the relationship user subject, and user resource or subject object. So those relationships, they are a group of attributes and permissions that they are actually awarded to an object based on the authenticated subject. They act on the volatile memory. This for sure means that once the copy is on, so the inode, in order to have that effect, they have to be brought to the volatile memory, to the RAM. Those actually, inodes, they control the content within an environment based on a hierarchical view. It means we have levels via which we have different controls. So let's talk about the bytes drawn by this Unix environment. We talk about a write of reading, a write of writing, a write of executing. So whether you'll be awarded a write of reading R, or you are going to be awarded a write of writing W, or a write of execution, which is X. Who are you? whether a simple user or a member from a group of students, group of instructors, technicals, group. It's a group. So the computer will recognize you as a member of that group. Or you are a process, antivirus, firewall, a specific process that the computer would accept his task. So other. Here, the group other classifies that the third member cannot be, it's not cannot, but it's not a user and is not a group. Thus, he is classified as other. But the three rights, they are the same. Read, write, execute. So the three, whether a user or group or others, they are to be awarded the read, the write, and the execute. Might be awarded all part. See the example here. On top, the read, write, execute for the user. Read, write only for the group. Nothing, none for the other. So it depends on the context, on the privilege, on the scenario, or whether all part or nothing to be awarded to a user. The relationship, the rights, subject, object. Read, write, execute. Mainly, the computer does not understand actually read, write, execute. We humans understand read, write, and execute. We humans. But the computer cannot deal neither with the read, nor write, nor the execute. Computer completely does not understand what is that. He understands only zeros and ones, the binary code, which is the binary code actually, which is the processor language. The processor do understand only bits, zeros and ones. There are 12 bits specifying those tasks, whether they read, write, and execute are given or not for a user, for a group, and or for an other. 12. 9 to specify the read, write for 3. Read, write, execute, read, write, execute, and read, write, execute. They are 9. Actually, 1 to set the ID of the user, and 1 actually for the group. Then specify actually the higher privilege or higher privileged users. Remember, we talked about the control. It will give you an access, capability to read. Yeah, okay. But who can delete? Who can remove? Who can change the name? This is another layer. It's a higher privileged capability that a specific user has to be given this task. So there is a bit, 1 bit. To specify this right means a user is awarded an access control definition based on 12 bits. The 9 to specify read, write, execute for 3 blocks, 9. 2 to specify the process ID and the user ID, something like that, and 1 to specify the right, whether you are able to delete or not. You'll be able to, actually it's the right of being administrator or super administrator, super user in the environment of Unix. A super user, it's a user that has a higher privileged right that can do such tasks. So this is a bit that specifies this right. This right means whether you have it or not. 0 or 1. 1 you have it, 0 you don't. So the system will specify that. This is actually nominated the sticky bit. The sticky bit is the one that specifies the byte given to you, a privileged user. You are able to delete and modify. Actually, this sticky bit is to be by default given to positive to a super user. Super user, you have the right to delete and rename and move and so on. So a super user is the administrator, is the main administrator within the environment. Is the privileged user. In the environment here, we talk about Unix mainly. So newly set distributions based on the Unix environment, they are actually given a more sophisticated view to the access control list. Yes, here, access control list. The access control list, we talk about the rights to do, whether upon the relationship subject-object. Those are the three groups and the three rights we were talking about. Any questions, please? I believe that everything is clear. We pass to the next, actually, access control mechanism, which is the role-based. Role-based actually is a scenario in which we use the roles to assign access to resource. But that's the role. An instructor is a role. A student is a role. An administrator is a role. So based on the role that the user is doing or is assigned, he will be accessing resources. So what the instructor accesses is not the same what the students access. It's not what the administrator or the administrative party accesses. So based on the functionality here, the role, a group of resources will be given. Resource number 1 to be accessed by all. Resource 2 to be accessed by those two only. Resource 3 to be accessed only by this role only, and so on. So the functions that a user can have specifies the resource to be reached. What the user can reach as resource based on his role, based on the role given to him. So the role, in conclusion, specifies the access control mechanism. If you reach the function here, the role, you are actor of this role, so you ask this resource. If not, no, you cannot, and so on. So as per this graph here, if you want this teacher, for example, this instructor, to access the database, the source number 2 here, what should we do? We have to draw a relationship in between this user, this instructor, and the role 2, because this role 2 accesses the resource. The user, the instructor, is not having an access to this role. If he gets an access to the role here, to the function here, he will be awarded an access to the resource. So the roles at the end of the day, they are the key controlling and actor that it gives an access or forbids the access to resources. Again, we have a matrix to draw that, to draw this relationship. The relationship, whether it is a role user relationship, we have a group of roles, and we have users. So, and there are actually access or not. The user might access this role, a user might not access this role, and so on. So it's a context of drawn relationship in between users and roles, because a role would give an access to the resource. Or another view, role object. We have a role and we have an object. So roles here, objects here. We have a role that acts as an object, or we have a role that do not have an access to an object, which is exactly what we're seeing here. A role has an access to an object. A role does not have an access to an object. So the role is the main actor here. And this is discussed whether a matrix. The role view, the role-based access control, is ruled. It's not a common sense understanding only. Still, the same technology is applied. if we are within an environment setting up the role-based access control mechanism, so the requirements they are displaying a part of similarity with the discretionary access control. What is it? So the first level via which we set up the role-based access control, which is the RBAC, is a very minimal functionality to be given to authenticated parties. The inputted data, which is the validated or the authenticated parties, from first view, they would be awarded a very minimal functionality. They would not be having any right except the very basic ones to make the system run only. This is said to be RBAC 0, level 0, rule-based access control level 0. Next level is the level 1, which is the same group of rules or roles awarded through the RBAC 0 plus a specific permission due to your role. No? When you talk about an instructor, he actually 100% have an access to the profiles of students, as per the example here, relationship student instructor. So by inheritance, the instructor might have the access to specific resources because he's an instructor. Role number 1, role-based access control level 1, gives us the minimal functionality plus the inheritance of the functionalities in plural that your role is having. If you don't have any inheritances, so you only award the RBAC 0 again. So you'll not be awarded any additional rights. RBAC 1. RBAC 2, next level, role-based access control level 2. It is the same role-based actually level 0, which is the minimum functionality. In addition to, there are constraints, there are relationships with other functionalities. Means you'll be accessing another resource in addition to the minimum functionality and other resources or other roles because of the relationship of your status or the relationship with your profile. We talk about constraints here. The constraints mainly they are actually to specify a way to use an entity or a resource inside the environment. Relationship. So the instructor has to give costs. The instructor has to see the student's profile and so on. So there are constraints to relate objects to each other. Based on those constraints here, there are functions, roles to be given to the respective subject. We talk about role-based access control. Noted. So it's the same. Level 0. In addition to the constraints. Constraints with other roles or other resources. Level 3. Still the same level 1, level 0, so plus both of them, the inheritance and the constraints. So level 3 is the minimum functionality in addition to the inheritance capabilities or inheritance feature plus the constraints feature. All the three, if they are gathered, 0, 1, and 2, those three, they give us the level 3. The entities, since actually those 4, let's say pre-described or pre-prescribed RBACs, role-based access control scenarios, they are actually on the basis of a group of entities. They are actually, all of them stand on the RBAC 0, RBAC 0, RBAC 0. And this RBAC 0 has come to an action due to a group of entities. Who is the doer? What is the right? What are the permissions? The role here, sorry, what is the, not the right here? We talk about the functionality, the capabilities, the permission, the privilege is the role. What is the function of this user is the role. Then the permissions, actually it is a right here. It's an example of the permission is a view via which we see the right given to a user. Then a relationship session, it's just a mapping, it's just a path between the subject and the resource for a period of time. The session is the path via which a user accesses the resource. And this path specifies the path itself and specifies the period of time. So it's a control, it's a way via which we draw a line in between the user and the resource, subject and object, session. It's a context of visibility. User to see the resource. Resource is seen by user. Great. A graph via which we draw all what we explained earlier. Level 0. From the level 0, the very minimal functionality, the basic one. Level 1 is a hierarchy to be added to the level 0. Level 2 is the constraints to be added to level 0. Both of them, since they are actually on the base of level 0, both of them they give altogether, not one only, both. If they meet, they are given the level 3. Level 3 is the inheritance plus the constraints on the base of the minimal functionalities. The 3 altogether, they give us a consolidated model. Entities, we were talking actually, and the graph to see the relationship between the entities. We see constraints. We see here actually it's a context of roles, functions, and we see actually permissions and what are the rights between the users and roles. So users have many relationships with roles because we have many users. So a student, how many students we have? So many. For example, a teacher, what are the roles he have? So many. So there is a many-to-many relationship between the users and roles. We might have actually a session to draw the path in between the users and the roles. The path here actually how to reach those roles or how to apply those roles, or even the time frame, for how long, since when till when. It's the role of the session. Then permissions based on the constraints, here, based on the view, the constraints they have to be seen here. Roles might actually give an access to resources. Permissions here, privileges. Might not also give an access. It's another permission, which is the denial. Constraints usually considered. Any questions, please? An example here we see the organizational hierarchical view between departments, starting from the top level until the bottom level. Top level, we talk about the managerial level, the director, and the bottom level, we talk about the technicals, the workers on field. In between, we have different managerial departments, and via which we may draw the roles accordingly. Level 3, level 0, and so on. Good. Attributes here, they have to be accessed, not attributes, but resources. They have to be accessed based on standalone rights, mutual and exclusive right to be given to a resource to be accessed by a user, a specific, let's say, subject. Here we are talking about a permission, a specific permission to be granted on a user, sorry, on a subject to a specific user. Mutual access control, or mutually exclusive, something like that. So specific access, specific permission to a resource by a specific subject. When I was describing to you now just in a while the relationship, for example, between the users and the roles here, we said that the session can draw many to many relationship. Means a user might have many roles in the sense of a teacher, for example, what he can do inside the system, inside the UA. Many functions, many functionalities. The many I'm saying here is a cardinality. So we talk about cardinality. How many elements from the entity is being utilized or is being interfered in the action. Cardinality. As if we're talking about the information integrity when dealing with the databases, when normalizing databases. Yeah, and prerequisite roles, it's a context via which we have to see if a specific user has passed by all the let's say, required roles. Means you cannot actually see the interface of transcript if you do not authenticate yourself. Even you are authenticated using username and password, you have to, secondly, provide that you are having a right to access the profile or the transcript of a given person. So we talk about prerequisite roles. Okay, I give you only an example, but the meaning of a prerequisite role means you are going to be accessing a specific resource based on the pre-assigned roles. You have to pass gradually, already past the level 1, the role number 1, the function number 1. Thus, you can access what you are actually willing to do, what you are willing to access, the final resource. Any questions, please? I'll stop the recorder and I'll take the attendance.
No, sir.